This video is for the submission of the ABB Robot assignment of PDE 3422 Robots and Manipulators class. The aim of the project is to create rapid code that allows the robot to write the initials of a person on a piece of paper. In my case it will be Z and T. In Autodesk Inventor a dimensionally accurate pen tool and a platform has been created, amongst other 3D models, to be used in the simulations. The 3D models are saved in SAT file formats which are possible to import to the Robotstudio software. SAT files store three-dimensional geometry information in a standard text file format. By using the accurate models in the simulation, it will be possible to test the code on the real robot after the simulation has been made successfully in Robotstudio software. The previously made pen tool is imported to Robotstudio as a geometry. The pen tool's frame needs to be moved to the tip of the pencil and only after can be saved as a tool in the software's library to be used later as a robot tool during simulation. The pen tool is attached to the robot and a home position is set using the linear jog tool. The parts in the 3D modeling software were intentionally created in the right orientation, this way saving time and extra work because they appear exactly at the required position. To make future changes in the target position easier, a new work object is added. First, an object surface with its borders needs to be created using 3 points on the plane, 2 on X and 1 on the Y axis. This surface can be used to define a plane and an origin for the new workspace. The work object and the targets need to be in the same orientation as the pen tool's frame for the robot to be able to reach them. A drawing with dimensions was made to make positioning the robot targets easier. Targets are created in relationship with the new workspace's origin instead of the original one, which was the base of the robot. As the new work object's origin was rotated, we also need to rotate all the targets, so their position will match with the table surface we want to draw on. The easiest way is to rotate them all around the work object origin's y-axis, adjust the height and copy the tool frame orientation. Now the required path can be created. Keep in mind that to achieve an accurate drawing and not to tear the paper with the pen, the tool needs to approach the targets completely when drawing. This can be done by changing the Z value. And the speed of the robot can be controlled by modifying the V value. By using a new work object, it is easy to move the targets only by changing the origin's position. When drawing, the pen should approach the first target on the paper completely with a low speed and on perpendicular to the paper. The path created can be synchronized with Rapid to create the rapid code and used or modified later. This is easier than typing in the code or using the controller, especially when it is a complex vector graphics path that needs to be followed. This code can be loaded to the robot using a USB drive. The robot draws the initials Z and T as expected. The video is played 2 times the original speed. Any 3D model created can be imported to the software as a SAT file and used as a reference or just as decoration. A work object can be created in any angle. Using this new origin as a reference, a target path can be created anywhere until it is inside the robot's workspace, meaning the robot can still reach the target. The workspace is created by selecting the X and Y axis and its intersection is used as the origin. This task will attempt to draw a Batman logo in the simulation on a surface that is not in a horizontal position. It is possible to create complicated paths using the AutoPath function to follow complicated vector graphics. Bear in mind that after creating the path, the orientation of the targets still needs to be aligned with the tool frame. Because a new work object's origin was used as a reference, it is very simple to change, modify or adjust the target positions to perform the real-life task in case the surroundings change. Our actual robot is mounted to a flat table. As we know the tool length and the height of the drawing surface compared to the table surface where the robot is mounted, all we had to do is to move our work object to a horizontal position in the right height. The logo has been drawn successfully. The video will be played with accelerated speed.